Last episode, your matrix lost the ability to reach most of the plane. Both columns collapsed onto one line, and this target became impossible. So here is a question we left hanging. Where did all those missing directions go? They did not vanish. They got crushed onto a single point along this hidden line. Every matrix quietly splits your world into what it keeps and what it destroys. And modern AI does this on purpose. Start with two arrows, they point different ways. So together they can reach this entire shaded plane, two genuinely independent directions. Rank 2. Now watch what happens when the second arrow swings into line with the first. The instant they agree, the second one stops adding anything new, and everything you can reach snaps from a plane down to a line. Rank 2 becomes rank 1, and you can see it without any picture at all. Look at the matrix. The second column is just twice the first, a copy in disguise. Two columns of numbers, but only one real direction, and NP tells you so. Rank 1. Three specialists join a team. The first two each bring something nobody else has. The third only repeats what the second already does. Your head count says 3. Your real capability is 2. That gap is rank. Now, the other half of the story. Here are 4 different inputs A, B, C, and D sitting on one particular line. Apply the matrix, and every single one of them lands on the exact same place, the origin. 4 different inputs, 1 output. This line is called the null space, the directions the matrix crushes to nothing. But why can you never undo it? The reason is the prettiest picture in this episode. And here is the prettiest picture in this episode. It is not just one line that collapses. The whole plane is sliced into parallel lines, and every single line gets crushed to its own single point. Watch. Red line, red point. Yellow line, yellow point. Blue line, blue point. Now try to run it backwards. You are handed the red point and asked which input produced it, but 5 of them did. An entire line of them did. There is no way to choose. It is a shredder, many pages in, one bin of confetti out, and no way back. That is what it means for a matrix to be uninvertible. So a matrix keeps some directions and crushes others. Here is the beautiful part. Those two numbers are not independent. They are a budget. 2 dimensions. Go in. Right now both survive. Rank 2, nullity 0. But swing the second arrow into line with the first. And watch the bar. The moment the direction stops being kept, it becomes crushed. Green shrinks, red grows in lockstep. The total never changes. Rank plus nullity always equals the number of dimensions you started with. Nothing is lost for free. Every direction a matrix keeps is 1. It does not crush. Now add a dimension and watch the same law hold. One rung at a time. Add a dimension, 3 axes and a cloud of data filling all 3. Rank 3. Nothing crushed yet. Now climb down the ladder, squash it once. The cloud flattens onto a plane. Rank 2, nullity 1. Again the plane collapses onto a line. Rank 1, nullity 2, and once more every point onto a single point. Rank 0. The budget was 3 the whole way down. Now the payoff on real data. 3 columns from a real table, height in centimeters, height in inches, and weight. 3 features, 3 axes. Plot them. Look at the shape. That is not a cloud filling space. That is a pancake, a flat sheet, floating in 3 dimensions. Let me turn it edge on. From here, it is almost a line. Your 3 features were never 3 independent things. Centimeters and inches are the same measurement, wearing different units. 3 columns, 2 real dimensions. And this is what real feature tables look like. 10 columns. But centimeters and inches are twins. Age in years and age in months are twins. Steps and kilometers. Heart rate twice. Run the rank and the truth comes out. 3. 10 columns of numbers carrying 3 columns worth of information. That gap is not a rounding error. It is why compression works at all. And it is the bet behind LoRA. When you fine-tune a giant model, the change you make to its weights turns out to be well approximated by a low-rank matrix, so you can adapt a huge model by training a sliver of it. Same idea, industrial scale. 5 lines proves it on your own data. Stack a column with its own unit conversion. Ask NP for the rank and it says 2, not 3. Subtract to get the nullity and the budget always balances. The full notebook is in the description. The map so far: vectors, transformations, composition, the determinant, the dot product, and solving systems. Today, rank: how much of your world a matrix actually keeps. You are here. What it buys you. Rank counts the directions that survive. Nullity counts the ones crushed, and the two always add up. Real data is almost always low rank, which is exactly why compression and low rank fine tuning work at all. Next stop on the map, the same arrow written in two different sets of numbers, and why picking the right coordinates is the trick behind eigenvectors, PCA, and attention. Next, the same arrow, two different sets of numbers, and why choosing the right coordinates is the whole trick behind eigenvectors, PCA, and attention. Thanks for watching and keep exploring. Next time, change your basis. Please like and subscribe Third Eye Labs if you enjoyed this video and let me know in the comments.